All right, everybody, we made it to chapter 4, sections 1 and 2, the outline for the chapters. For number 1, we have what are factors in plain language? A factor is a number that divides evenly into another number without leaving a remainder. So let's see, a factor of 6 would be 1 and 6, or 2 and 3. So they're all factors of 6. Number 2, how are factors and multiples connected? Factors and multiples both involve multiplication. Factors are what we multiply to get the number. Multiples are what we get after multiplying the number by an integer. Example, if A and B are whole numbers, A times B equals C, then A is a factor of C and B is a factor of C, and C is a multiple of both A and B. So example 12, 3 times 4 equals 12. We've got the 12 is, the factors of 12 are the 3 and the 4. And then, so 12, 3 and 4 are multiples of 12. Let's see, number 3, how do you find factors of a whole number? You use your knowledge of multiplication tables or systematically divide. So you're trying to find the multiples of 12. We know that 12, like 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Or you could do 12 divided by 1 is 12, 12 divided by 2 is 6, 12 divided by 3 is 4. So that's how you can find the factors of a whole number. What is the factor test? Number 4, it says the test only numbers that are no greater than the square root of the number. So say we're doing a factor test on the number 144. To know what numbers you need to kind of look at in order to see what the factors of that number are is you take the square root of the number, like the 144, which gives you 12. So that means we only need to look at the numbers like 1 through 12 in order to find what factors are relevant for that number. So like say you did a test like for 2, it's 2 and 72. And then you do 3, 3 and 48, 4, you get 4 and 36. You try 5, it doesn't work. 6, because it has to go evenly. So 6, you have 6 and 24. Number 7 doesn't go evenly. 8 does 8 and 18. 9 does 9 and 16. 10 doesn't work. 11 doesn't work. And on 12, you have 12 and 12. So that gives you the factors of 2, 3, 4, 6, 8, 9, 12, 16, 18, 24, 36, 48, and 72, all for the number 144. Number 5, it says the divisibility theorem states that a natural number n is divisible by 2 if and only if its units digit, which is like the ones digit in base 10 counting, is 0, 2, 4, 6, or 8. And then a natural number n is divisible by 5 if and only if its digit is 0 or 5. And a natural number n is divisible by 10 if and only if its units digit is 0. So only if those numbers are in the ones place is it going to be divisible by those numbers. So then we have number 6. Odd numbers are not divisible by 2, and even numbers are divisible by 2. I'm still iffy on number 7 and 8, so I'm not sure. I will add a insert into the video once I get a little bit more understanding on all of this. So section 4.2, prime and composite numbers. So what is the definition of prime and composite numbers? A prime number is a natural number, which is like a counting number, like 0, 1, 2, 3, 4, 5, 6, but no decimals or fractions. So it's a natural number that has exactly two distinct factors, itself and 1. So like 2, 3, 5, 7, 11 are all prime numbers. So they're like for 5, the only number that 5 is divisible by is 2 and or 5 and 1. And 7, the same thing, 7 and 1, 11 and 1, 3 and 1. Now, composite numbers are natural numbers that have more than two distinct factors. So if we have 6, so you have 1 and 6 and 2 and 3. So that's more than the 2 prime, so it's considered a composite. Oh, like B down here says the number 1 is defined as neither prime nor composite. So it's its own special thing. It's the only number in all of the numbers that are neither prime or composite. All right, so A says factor trees, example 30. So in order to create a factor tree, you're kind of finding all the different factors that make up that number. So I start with saying 30 is broken up into 2 and then 15. And what we're doing is we're trying to break each piece down to where it's prime. So like the 2 is prime, and then on this side 15 is not prime, so we need to break it down. So we're going to break it down into the 3 and the 5. So 3 and 5 are both prime. So that would be the prime factors of 30. Let's see. So their factors are 2, 3, and 5. So you have the 2 here, the 3, and the 5. I did 64 just to kind of show you an example. So with 64, you've got 64 as 2, which is prime, and 32 is not. So then we break 32 down into 2 and 16. The 2 is prime. And then the 16 we break down into 2 and 8. The 2 is prime, but 8 is not. So then we break it down 2 and 4. The 2 is prime, but 4 is still not. So then it breaks down to 2 and 2. So if you count, there's 1, 2, 3, 4, 5, and 6. So that the factors of 64 are either 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. So 2 times 2 times 2 times 2 times 2 so 2, or 2 to the 6th. So those would be the factors of 64, just to give you an example. C, prime factorization is when a number is expressed as a product of primes. So it's because you could say like 42 is the same as 2 and let's see, 2 is 21. So that is not really labeled as, sorry, that's not really, all the numbers that are factors are not prime in this equation because 21 is not prime. It can be broken down into 7 and 3. So what it means is the expression has to be all prime numbers. So 42 would be the same as 2 times 3 times 7 to make it a prime factorization. All right, so we're going to try a stacked method. The first one we have, the example is 45. So what we need to do is find out what the prime factors of 45 are. So first we start with like 2. 2 doesn't go into it because it's not even. Then we have 3 doesn't go in evenly. 4 doesn't go in evenly. And then we have 5. So 5 times 9 is 45. And then we need to find, because 9 is not prime, so we need to go down and see what factors make up 9. So we have 3 times 3 is 9. So that gives us the prime factors of 5, 3, and 3. So if you take 3 times 3 times 5, it gives you 45. So 40. So 3 times 3 times 5 is 45. So those are the prime factors using the stacked method. I'm sorry. So next one we have 60. So if we start with 60, and we need to find the prime. So we know it's an even number, so I would start with 2. So 2 and 30. And then it's still not prime, so we need to divide it out more. So we know it's even, so we're going to do it by 2 again. So do 15. Can't do 2 anymore, but we see 3 will work. 3 times 5 is 15. And then 5 and 5 is 1. So our least common, or our prime factors are 5 times 3 times 2 times 2. And if we have 115, we're going to start at 115. Let's see, 115. So 115 divided by 5 is going to be 23. And then 23 is a prime number. So we're going to so the prime factors are 5 and 23. All right, so if we want, we could try another one. Say factors of 80. Prime factors. So we know it's even, so we can do by 2. 2 into 80 would be 40. 40 can go in 2 times, so that would be 20. And 2 would go 10. And 10 can go to 5. So the factors of 80 would be 5 times 2 times 2 times 2 times 2. All right, let's try 62. So with 62, we've got 2 would be 31. And 31 is prime. The only number that can go into it is 31. So our factors of 62 are 2 and 31. All right. So we have the Venn diagram examples 30 and 108. To find the greatest common factor between the two, you find the factors of each number. So you have the factors of 30. We have, we have 1 and 30, 2, 15, 3 and 10, and 5 and 6. And then for 108, we have 1 and 108, 2 and 54, 3 and 36. Then you have 4 and 27, and then 6 and 108. So all the factors that they have in common are 1, 2, 3, and 6. All the numbers here, all the numbers here in the middle are the greatest common factors. But the largest common factor we have in common is 6. So it's the larger number, the greater number that they have in common. So another example we have with the Venn diagrams and finding the greatest common factor would be for 45 and 78 if we compare their common factors. So 48 breaks down into 1 and 45, 3 and 15, and then 9 and 5. Then we have 78 does 1 and 78, 2 and 39, 3 and 26, and 6 and 13. So the largest number they have in common is the 3. So their greatest common factor is 3. All right, so for B, we have 24 and 45. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then 45, we have 1 and 45, 3 and 15, and 9 and 5. So the greatest number they have in common, let's say, is the 3. Okay, so now we're at number 2. We have using Euclidean method to find the greatest common factor. So we're still finding the greatest common factor. This is just a quicker way to find the common factor for for larger numbers. What you do is you start by comparing the smaller, like dividing the smaller number into the larger number. So you have 240 divided by the 580. And what we're trying to do is we're trying to divide it out until we get to the 0 with no remainder of 0. And then the divisor that goes with that equation that does give you the 0 remainder, that is going to be your greatest common factor. So first we start with saying, okay, the 240 divided by 580, we can go in 2 times with a remainder of 100. So then we take the remainder that's left, the 100, and we move it up to the divisor spot. And then we divide 100 into the previous divisor, the 240. So now we have 100 divided by 240. And that gives us 2 with a remainder of 40. So now we're going to take that 40, because we still have a remainder, we're bringing that up to the new divisor. And then we're bringing over the 100, the previous divisor, and it's now the dividend. So we have 40 divided by 100 is 2 with a remainder of 20. Still have a remainder. So we're bringing up that 20 to the, now it's going to be from a remainder to a divisor, and we're bringing the 40 over from the previous one, and it's now the dividend. So 20 divided by 40 is 2, because 2 times 20 is 40. So that gives us that 0 remainder, and this 20 is now our greatest common factor. So if you divide like 580 divided by 20, you get 29, and 240 divided by 20 is 12. So that's the greatest factor that both of those numbers have in common. So then I found a little bit more visually way to see it online. It kind of just gives you a little step down. So this one is for the greatest common factor of 848 and 570. So you first start with a smaller number, the 570, and you divide that into the 848. So that gives you 1 with the remainder of the 278. So then that 278 is now your divisor, and you're bringing down the previous divisor and dividing it into that. So you have 278 divided by the 570 gives you the remainder of the 14. So now the 14 is your new divisor, and you're dividing that into the previous divisor. So then you have 14 times 19, or 14 divided by 278 is 19 with a remainder of 12. So now your 12 is your new divisor, and you're dividing that by the previous divisor. So you have 12 divided by 14 is 1, gives you a remainder of 2. So now you have 2, you're bringing down the 12. The 12 divided by 2 is 6, and that gives you the remainder of 0 that we're looking for. So in this way of thinking, the 2, which is the last divisor that we had, is our greatest common factor. So that is the largest number that factor that they both have in common. Because you have 848 divided by 2 is 424, and then 570 divided by 2 is 285. Okay, if you have any questions, let me know. It looks a little trickier than it really is. Okay, so we're having prime factorization to find the greatest common factor. So what that is, like I said before, the prime factorization is a number broken down into the prime factors that make it up. So we have, for like 10, we have 2 and 5, because both 5 and 2 are prime. Because you could have like 1 and 10, but 10 is not prime. And then for 15, your prime factors are 3 and 5. And then to find the common factor between the two, you find which ones they have in common, and it would be the largest number. So the greatest common factor for 10 and 15 is 5. All right, so now we're switching gears. We're going to be working on the least common multiple. I know it's a little, trying to figure out what the difference are. It's a little tricky, but what the least common multiple is, it's the smallest natural number that is a multiple of 2 natural numbers. So say it's like you have 5. The multiples of 5 are 1, 5, 10, 15, 20, 25, 30. So those are all the multiples. Like anytime you add something to a number, that's what the multiple is. So the multiples of 7 are the 7, 14, 21, 28, 35, 42, so on. To find the common multiple between the two, the least number is what number 1 is asking. So the least common multiple between 5 and 7 is actually the 35, because that's the multiple that they each have in common, and it's the smallest. You could probably find one later, like further out, but it wouldn't be the least. So it's the intersection of the set of multiples of 5 and multiples of 7. So A says, use Venn diagram to find the least common multiples of 8 and 11. So I listed all the multiples. So it's not the factors that make up the numbers, it's what that number times another number to give you the multiple. So like 8 times 1, 8 times 2, 8 times 3. So 8 times 1 is 88, or 8 times, sorry. So we have 8 and 11. So 8 times 1 is 8, 8 times 2 is 16, and 24, 32, 40, 48, 56, 64, 72, 80, and 88. And then for 11, you count up by 11. So it'd be 1, 11, 22, 33, 44, 55, 66, 77, and 88. So when you finally get to one that is, they match on both sides, that gives you the least common multiple. So it's the lesser amount that they have in common, not the greater, like the other ones we were working on. So now we're going to kind of mix the two together. We're doing factor tree method, which factor trees just kind of give you a visual of breaking it down of the different parts of a number. So we know the factors of 4 and 9. So the factors of 4 are 4 and 1 and 2 and 2. But in order to do that, we can like take 4. So we know 4 is 2 and 2, and we know those are prime numbers. And then we have 9. We're trying to break it down to the prime. So we have 3 and 3 is 9. We can do like 2 and 1 and 2 and 1, or 3 and 1 and 3 and 1. So this one was a little tricky because normally you wouldn't go all the way down to 1, but because they didn't have anything in common other than 1, that was the greatest common factor. Now the least common multiple would be for this one to multiply the 4 times 9, because they don't have anything in common. So it would be the 36. So 9 times 4 is 36. Now this one is a little bit better. We have 78 and 56. So first we need to like find the prime factors of the 78 and the 56. So we would take 78. I always start with 2, so I break it up into 2 and 39. Now 2 is prime, so we're going to leave it there. And then 39 can be broken up to 3 and 13. Now those factors are both also prime, so that those are your prime factors. You have 2, 3, and 13. So those are those right there. And then for 56, same thing. We've got 56 into 2 is 28. And then the 28 can be broken down into 2 and 14. And then 14 can be broken down to 2 and 7. So we have the 2, the 2, the 2, and the 7. Those are all the prime factors. So those we have listed here. Because none of those numbers can be broken down any farther, so they're the prime. Now, in order to find the greatest common factor, you compare the two lists of factors and you find out which ones they have in common, and then you find the greatest one. So on this one, it's actually 2. They only have the 2 in common, so the greatest common factor would be the 2. And then for the least common multiple, I just wrote out the same factors, and you need to find the multiples that they have in common. So they have 2, 3, 13 for the 78, and then 2, 2, 2, and 7 for 56, but they only have the 2 and 2 in common. So these kind of equal 1. So you have 1, 2, 3 2s. You have 1, 3, 1, 7, and 1, 13. So then you would multiply all those together to get your least common multiple. All right, so number 3, it says using the stacked method, find the least common multiple of 78 and 56. Now this is actually a little bit easier, this method, I think. So it's kind of using the previous stacked method that we did, but it's comparing two numbers instead of just the one. So what you do is you take the two numbers and do 78 and 56. And then we know they're both divisible by 2 because they're even numbers. So we would start with the 2. So 2 divided by 78 would be 39, and 56 divided by 2 is 28. Now, there's no other numbers that you could think of that would go evenly into 39 or 28 other than 2. So this would be your greatest common factor, but in order to find the least common multiple, you would cross multiply here. So you would have 78 times 28, and then 56, or actually that would give you 2,184. So you don't have to cross both ways, but it just shows that it's the same both ways. So you have 56 times 39 also gives you 2184. So those are the common multiples that they would have in common, and it's the least the least number possible. All right, I'm going to write out some examples for you for the stacked method comparing the two to find the least common multiple. See if it'll help make a little bit more sense. So we have 24 and 36. So first we start with 24 and 36. So we know they're both divisible by 2 because they're both even. They have 2 and 12 equals 24, and 2 and 36 divided by 2 and 18, sorry. So 2 and 12 and 2 and 18. So they're both still even, so we know they're going to go in there twice. So we have 6 and 9. And then both of those numbers are both divisible by 3. So let's do 3. You get 2 and 3. So both of these are prime, the 2 and the 3, so we know it can't go any further. So what we need to do now is you need to cross multiply the 24 by the 3 or the 36 by the 2, which is going to give you the same thing. So we have 24 times 3 is 72. And then 36 times 2 is 72. So your least common multiple is 72. And then let's try 108 and 225. All right, so I know they go in 3 times to start with. So 108 divided by 3 is 36. And then 225 divided by 3 is 75. So then the next one, that's all they can go. Well, no, it could go 3. 3 would be 25. So 3 would be 36 divided by 3 is 12. And then I think that's it now. So you would do 108 times 25, and then 225 times 12 would be 2,700. And then 225 times 12 is 2,700. So the least common multiple, it goes 2,700.